Hi, welcome to another podcast of Electronica Exchange. This is Aswinth, editor and co-founder of Semicon Media, and today we'll be talking about the innovation in automotive electronics and the semiconductor integration. And to do that, I'm very excited to have Mr. Hitesh here, who is the Vice President and India Country Manager for NXP Semiconductors. And Hitesh has been with NXP for the past 15 years, shaping the automotive ambitions of India in automotive, AI, and IoT and beyond. So, Hitesh, thank you so much for joining us beyond your busy schedule.
Thank you, Ashwin, for inviting me here. It's my pleasure to be in Electronica and being part of this discussion. Thank
Great.
you.
So, before we talk about automotive electronics and NXP, let's start with something about yourself. So, can you tell me how your journey has been in the semiconductor industry for the past 15 years?
Yeah, I think the journey is much longer. I have my journey is more than 30 years, or not more 30 years in this. I started with the state-owned company called Semiconductor Complex Limited in Mohali in Chandigarh.
Okay.
So that was a government company, my first job. And we were building at that time the lowest power hearing aids and the lowest power pacemakers.
Okay.
So I think my first exposure in my company was not only to make the low power designs, the analog centric designs, but also the design mainly for the healthcare kind of applications. So that was the fantastic exposure I got to look at not only at the chip design, but also how do we build a system, right? Which is not only mainly, at least for India market, that was the focus. And a lot of collaboration at that time was happening with key institutes like IIT Delhi,
Okay.
with SCL Chandigarh, and I think, and also with other institutes like Alimco, Artificial Limb Manufacturing Company. So those were the days when I think electronics or semiconductor was kind of starting up in the country. So I think after that, in 2000, I moved to Bangalore, started working into, I would say, companies who are doing microcontrollers. After that, I continued my journey towards companies who are doing high-speed serial interfaces, high-speed links. And for last, I would say 18 years, I'm in NXP, building high-performance mixed signal at the same time. Now we are moving towards AI on the edge kind of topics.
That's wonderful. So, if you want to explain what NXP is doing for the automotive industry to someone outside the industry, how would you explain it? What is NXP's role in automotive industry?
Uh, very interesting question. But I think NXP, I would position ourselves as the thought leaders
Okay.
for the automotive industry, right? If you see for last 5-10 years, and even if I take forward next 15 years, the whole innovation and the growth or the transformation in the automotive industry is all led by electronics, right? So even I would say drives are becoming electric. All the things that you are seeing, right? So whether from the cockpit or from the engine control, everything is where you are having electronics. So NXP is providing end-to-end solutions for automotive. So be it on the sensing, be it on the car radar, we are having the best-in-class product. Be it in the battery management, we have the best products for electric vehicles. We have the all kind of microcontrollers, microprocessor for car application, for low end like engine control to your window opening, to your central brains in the car. So I think we are there. We have the best in class connectivity, right? Starting from the CAN, LIN, FlexRay to Ethernet to the high speed Ethernet. I think we have those technologies available. So I think NXP is the only company which is a single stop solution for, I would say, for the car electronics. And I think this we have built. And now on top of that, we are looking not only, I would say, at the component level, we are also looking at the system level, right? So how do we create, I would say, fastest experience or better experience for our customers to, to bring in the platform faster and better? So how can we even provide a system level integration based on, I would say, based on NXP solutions? So we are thought leaders. Even some of the OEMs, even they kind of engage in the discussions with us, dear NXP, how our car architecture should look like. Should it be a domain based? Should it be a zonal based? How many zones we should have in the car? So I think from that perspective, we are driving how the future of the automotive is going to look like from the very conceptual perspective.
Perfect. So of all the solutions you just mentioned, like be it battery management system or connectivity or other solution NXP offers, what is the most exciting thing for you which you think could really change the automotive industry in future?
I think everything is exciting. Every solution is very, very close to my heart. But if you ask me to pick up one, or I would say two,
Hmm.
one is definitely, I think, ADAS, which is automotive driving
Driver assistance.
assistance, because we are the cars are going into autonomy more
Right.
and more.
Right.
So how we are building the best in class sensors
Mhm.
around the car, which gives more comfort feeling, more safety,
Right.
at the same time make the driver more aware. So I think, and in this respect, we are saving human lives. So I think that's a technology that I'm very, very upbeat about. So most of, I think very soon we'll have the cars which are going to level 2, especially in India ecosystem. And we are already looking at level 3 and level 4. And these are all enabled by the advanced ADAS system, which is mainly on radar. And the best part is that the previous generation radar system are based on LiDAR.
Okay.
And LiDAR is not an, I would say, is not a cost-effective kind of technology. While when you look at radar, it's very cost-effective. And I think we have kind of give the high resolution 4D imaging technology with help of our advanced radar technology. And we have both sensing as well as processing happening at the edge for the radar. So that's my first part, which I'm very, very excited. My second part is also, I think, we are bringing, I would say, edge computing, right? So, advanced computing, AI on the edge,
Okay.
in the car. I think that is going to create another transformation, because what is happening is, like, the big brains are coming inside the cars, and now the cars have to take some decisions. So we are bringing, so the decisions, when car has to take a tough decision, it need not to go to cloud. How can I bring the AI
To the edge.
already inside the car? A car running at 200 kilometers per hour does not have time to send the data to the cloud and wait that when the data comes back and then it takes a decision. So the whole decision making using the edge AI processors will all happen inside the car. So that's the second, I would say, key technology that we are working and we are bringing to the market.
Understood. Perfect. So, sir, this whole automotive industry, it's kind of evolving very fast. There were ICE engines, then hybrids, electric vehicles, now software-defined vehicles. So, how do you see the semiconductor requirements changing along with this evolution?
Yeah, I think, as I mentioned, right? So this is semiconductor requirements are changing big time over time in every domain. As I said, on the connectivity side, so we had CAN, LIN, FlexRay kind of connectivity. So where the links are not more than 10 kbps or 100 kbps, and when I talk about Ethernet, it's going up to 100 MB, 100 gbps kind of links. So we do have high speed links in the car. When we talk about processing, right? So we were having basic microcontrollers, but now we are having high end processors, zonal processors in the car, which are the brains of the car. On top of that, we are bringing, I would say, edge AI on the edge. So AI processors are also coming, which are kind of changing. Third thing is battery management. How we do the battery management more accurately. So because you have, when you go to electric vehicles, there's a range anxiety and those kind of things. How do we predict the range much better, looking at the health of the battery in a much better way? And last but not the least is, when we are doing all these kind of things, they should be safe and secure. So when more and more electronics is coming, then you will ask, whether my safety is taken care properly, right? Are these devices, are these car functionally safe? If in case part of electronics fails, will my car run without any failure? Will my brake work? So I think how every piece of electronics, or which we are transferring from mechanical to electronic domain, how we are taking care of functional safety. I think that's also, I would say, a clear USP from our side. So I think these are the, I would say, I would not call it as challenges. I would say opportunities and innovations that we are bringing into the automotive world. And the last that you might have heard about software-defined vehicle.
Right.
So I think that's the next step that we are moving into.
Wonderful. So, this is just a quick imaginary question here. So, how do you think the car of the future would look like? Like, how many sensors will be there? Because we are talking about battery management sensor, battery management system having its own sensor, the braking having its own sensor. So how many microcontrollers or different technologies will be used in the car of the future? What do you think?
Yeah, I think it's very difficult to say because the technology is constantly evolving, and the integration is also going on at the same time, right? So earlier, for example, if I have a big zonal processor with 100 cores, so that processor can do a lot of functions which you are doing with 100 microcontrollers.
Okay.
Right, so on one side we are bringing new technologies, but at the same time we are also increasing our integration level. So I think one of the things which is happening, and I think this is what I touched upon in my previous point, is the software defined vehicle. So I think the whole paradigm is changing. So when we talk about software defined vehicle, so this is, I would say, making your cars future ready.
Right.
This is, for example, so today if I put a processor in the car, right? So today's car are using 15, 20, 30% of the capacity of the processing power. So 70-80% of the processing power is for the future use.
Okay.
Right. So the whole SDV architecture, it gives complete, I would say, control to the OEMs.
Okay.
To the Tatas, Mahindras, BMWs of this world. They have a complete control on how the architecture will look like, how the experience inside the car should look like, what all feature they will put in the current version of the car. At the same time, any upgrade that they provide in the future, so that will also be kind of downloadable. So your car will be also future ready because we are using only 30% of the hardware capacity. So they are future upgradable. So that's where I keep on saying that we are making with the SDV or with these kind of technologies, car not a depreciating asset, but an appreciating asset.
Okay.
So your current car, so it's in best of its avatar when it comes at the showroom. So once it comes out of the showroom, it starts continue to lose value.
Right.
But now when your car comes from the showroom in an SDV, it has the basic functionality.
Okay.
But as it experiences your environment, your road condition, your personal preferences, also continue to download the new things. So I think it is not depreciating in the value.
Okay.
The value remains the same because hardware is almost remain the same.
Okay.
So the upgradability is all in software.
Understood. So Hitesh, you're also leading the analog mixed signal IP or AMS IP. Can you explain what this is and what solution it does provide to the modern automotive industry?
No, I think really fantastic question. If you see, see our whole, the actual real world is all analog.
Okay, right.
Right. So when we talk about these high-end processing, AI, they are all digital.
Right.
So the interface between the analog world to the digital world is all through this analog circuit design.
Okay.
So I think we play a significant role. So I coming from the analog and RF community, right? So as from the design, I have teams across the world who are doing these kind of designs. For example, when you talk about radar, so radar is a 77 gigahertz front end. Okay. So how do we do, I would say, the radar functionality? So it's an RF and analog kind of a block where we send a pulse, it is detected and it is received back. Okay. What kind of a pulse, what kind of a phase shift, how do we detect that? So all those functions are not done mainly in digital, but many of those functions are done in analog and RF. Similarly, you talk about battery management, right? So when I say battery management, so what we do not only measure, so every cell is measured. If your battery pack is, every single cell is measured for the voltage, for the health, we also measure the impedance of that cell. So that provides an accurate, you can say, view of the health and the charging condition of that cell. So, and all those kind of measurements accurately we do with the analog circuit design.
Right.
The third thing is when we talk about this, I would say high-end processors, right? So they are working at gigahertz kind of speeds. So the clocking mechanism, you can say the power management. Some of the power management is happening at a 12 volt. How you bring 12 volt to 3 volt, 3 volt to 2 volt, 2 volt to 1 volt. So all this voltage islands that we make, how this clocking island we make. So this is all done by the analog and RF engineers. So I'm proud that we are able to make significant, I would say, impact into this world of automotive and electronics.
Perfect. So when we talk about solutions for automotive industry, one non-negotiable thing is security and reliability, because it's going to be a critical application. So how does one ensure safety for these kind of critical applications when you're providing solutions for automotive industry?
No, absolutely. I think this is I touched upon this question in the past. This is not an afterthought.
Right.
This has to be the part of the design, and we do specific design keeping the functional safety in the loop for any of my critical chips, right? So I have a functional safety engineer who is there, who also looks at the architecture, who makes sure that every chip, every function, every component inside the car is following certain protocol, and we have defined protocol, functional safety, right? So whether you are SLB, CD, or D is the highest. So many of our functional critical chips are SLD standards, and we actually communicate this. This is there in our data sheet. So that is at the component level, but at the system level as well, I think we also take care of a lot of things that makes the car a functionally safe car. So for example, right, so if in case and the third thing which you also talked about is about security. Now, when I said about the zonal architecture or domain based architecture, it is also very important for us to have the right partitioning inside a car. Right? Because why you make different domains? Because there can be maybe a driving domain, there can be an infotainment domain, there can be a sensor domain, so there can be a battery management, or there can be so there can be different domains, or you can define whichever way. And the idea is that we would like to have a good isolation between these domains, so that if there is something which is happening not so right in one domain, should not impact the other domain. And for certain domains, for example, you can say drive domain, I would like to completely keep it isolated from my communication domain. The reason is that somebody should not come through a communication channel, through an infotainment channel, and try to hack my car. So I think, so two parts. One, functional safety, that how things are functionally safe. If a critical function is failing because of certain reason, how there is a backup which is available. So those are the thoughts as part of the architecture. And then second part is how do we do the partitioning so that the cars are not susceptible for any security attack and those kind of things.
Okay, perfect. So how do you see the Indian market, Indian automotive market? Do you see where do you see the adoption for these kind of solutions? How do you see the market adoption for these solutions?
I would say Indian market is almost the best in class. If you look at the OEMs,
why would that be?
No, because I think Indian market, the consumer are looking for the best of the feature, right? All the best of the cars which are produced in the world, they are all available in the India market. India is growing as a market, one of the biggest growth market also in automotive. And from that perspective, I think people will fall short if they are not bringing the best in class features to the cars. So I think my customers in India, right, so they are looking at what are the best features available, and they are trying to get the same features in the next generation car. And look at all the OEMs, right? You talk about Mahindra, the XCV. So I think so they have the best in class feature, and many of means the technologies I think are used from NXP by the Indian OEMs in defining into ADAS solutions, into ultra wideband kind of car key applications, into battery management, into connectivity solutions, and even on the various kind of microprocessor, microcontroller solutions.
Yes, right. So based on our discussion, I was able to understand that there are solutions with edge AI, there are solutions with connectivity. So automotive solutions seem to combine all these domains. So how do you see each of these domains influencing each other in an automotive sector?
Yeah, I think this is exactly this is a very good question, and I think this is how we look at when we are addressing different you can say these domains. So the way I look at the technology portfolio, NXP is a technology provider. Chip is an outcome of that. But end of the day, so with my technology, it is your imagination, it is customers' imagination, it is OEM's imagination, that how they use this technology to come with the best-in-class solutions, right? So, for example, the same microcontroller can go into, I would say, into a consumer device, can go into an industrial device, can also go into an automotive device. So we need to. So I think from that angle, we divide like humans, right? So they have what we do, we sense, we think,
Right.
we connect, and then we act. So we are also dividing our technology into these four pillars: sensing technologies, thinking technologies. Think means where we have microprocessor, microcontroller, right? All kind of portfolio, even crossover processors. Connectivity, all kind of connectivity, NFC, ultra wideband, radar, right? So all technologies, and then we have actuation technology, power management. How do we drive trains, battery management? So we divide into these four pillars, and for an automotive segment, they pick the right technologies which are required, like radar for sensing, right? Different kind of microcontrollers, different kind of connectivities. Some connectivity is only valid in consumer domain, right? We don't use Wi-Fi, I would say, in the automotive. So I think then the verticals pick up the technology, and there's also cross fertilization.
Okay.
For example, the industrial guys, they are mainly use ultra wideband, they are using Wi-Fi, but they are also thinking, or even cameras for, but they are also thinking, how can we use radar systems into our sensing? So I think things are evolving.
Right.
We are a technology provider. We look at the how, but how this has to be stitched together as a system. It all depends on innovation of our customers or partners.
Right. So Hitesh, I kind of got hooked with one line which you mentioned earlier. NXP is a technology provider and chips are just an outcome of it.
Yes.
That's wonderful. Can you touch a bit more on that? Like, how do you approach that ideology?
No, exactly. As I said, right? So we look at the ecosystem, that what are the needs for the ecosystem. For example, I see a car as a system, right? And if car has to run in an autonomous way, if car is like a robot on four wheels, right? What a robot needs? A robot needs sensors.
Right.
What kind of sensor? What are the cost-effective, best-in-class sensors I can provide? I start from there, right? So when I talk about, okay, robot has to connect inside, what kind of connectivity robot is going to have? And same thing on the processing side, same thing on the actuation side. So I think this is how, for example, ultra wideband. We thought this is a technology need, which and that technology we are putting into our mobile phones,
Right.
and ultra wideband is also going into my cars for car key application.
Okay.
So as I said, we are looking mainly at NFC. We had this technology, I would say, since maybe 2000, and it was only after 10 years, 2010, we started seeing adoption of this technology. And many a time we are ready with the technology, but you don't see sufficient applications, adoption. Now NFC, if you see near field communication, so we have these chips in our passports, we have these chips in our banking cards,
Right.
these chips are in our metro cards or in metro chips. So this is, you do a transaction, just tap and do a transaction. This technology, it was done in Philips in 95 or 2000 time frame. So I think same thing, ultra wideband, we see, okay, how do we create a technology where we can sense at a very accurate distance? Then radar, how can we reduce the cost of LiDAR based technology from $1,000 to maybe a $10 kind of a solution? So we look at that what are the technology which are missing, and sometimes we also acquire. Recently we acquired a company called Kinara.ai.
Okay.
And this company is doing edge, I would say edge computing. So they are into AI on the edge.
Okay.
So they are doing so the naming is called ARA processor. They are doing 40 TOPS NPUs.
Oh, okay.
Right. So so these are the some of the technology that we keep on adding. Now it's anybody's play to take up this technology, mix up, and come with a solution.
Perfect. Right. So when you talk about car of the future, let's say 5 years from now, a car of the future, what are you most excited about? Which technology do you think will be a breakthrough for the automotive industry?
I think the car of the future, the most interesting technology is, I say, when we have full level 5
Okay.
autonomous kind of driving.
Mm.
And so when you have you are going in a car like a passenger,
Mm.
and also you need not to own a car,
Okay.
right? So why you would own a car when just at the
That
click
is
of a button
right.
the car will come at your door? You just enter into the car, go to your office,
Mm.
and then leave it there.
Mm.
So those are the times which I feel very excited about,
Mm.
and that's the level of autonomy we would like to reach. And I think the days are not far. Maybe 10 to 15 years, we might reach to that level,
Right.
with the kind of advancement in the technology that are happening around this time.
Perfect. So yes, I am done with all my questions here. I think a lot of people would have understood what is automotive electronics and what are the advancements now. But is there anything you would like to add up to this podcast? Anything in particular?
No, I think as in India, we are doing fantastic work into the field of electronics and systems. I would say in the last, I am in this, I would say, industry for last 30 years. As I said, I started my job in semiconductor. It's a government, it was a government-owned company 30 years back, and still now it is there. So we started the journey from there. We were designing chips, designing components. But now the game is designing systems. So my only advice to the young entrepreneurs, to young engineers, is to start thinking more and more in terms of systems.
Okay.
Right? So it can be systems for the automotive industry, it can be systems for the industrial, it can be a fire safety system that you would like to create. So I think that's the need of the future. And more intelligence is coming on the edge. Of course, we have a cloud. We talk about chat GPT, we send a question, it goes to the cloud, we get an answer, we get a response. But more and more evolution is happening on the edge.
Okay.
If you just assume that you go to a doctor, the doctor has a device, and the device, of course, you give your history to the doctor, and the device listens to it, and he does the device does the diagnostics of yours, and come there. Okay, these are the things. So if we are bringing, and those kind of things are possible because there, the device is sitting with the doctor. You are not sharing your data on the cloud, so the security is taken care. It is real time, right? So because the car, as I said, is running at 200 kilometers per hour, it has to take a decision. The decision has to be taken on the edge. Same thing in the industrial applications, right? So you have a safety critical data. If a machine has to take a decision, then it has to be taken in that closed loop. So more and more applications are coming up with edge AI, with agentic AI. So think about edge AI in the same framework of agentic AI. A lot of applications can be developed which will make things more and more autonomous. We are not only talking about cars, but half of your factories can be autonomous. We talk about dark factories. This is a reality, and this is where the future is going to be. But the only advice that we don't continue to copy things from outside, we start thinking about the systems, we start designing, defining, and creating systems for the India and for the world.
Perfect. I think that is a very important and wonderful message coming directly from the Vice President. So thank you, Hitesh. Thank you so much for your time and having this conversation.
Thank you. It was a
wonderful.
pleasure talking to you.
Yeah.
Thank you very
Thank you.
much.